in this video. Hello everyone, and welcome to our 13th video on the channel. And actually, this is the last topic in the Algebra 1 series. I know, it's crazy. We're going to be moving on to the Algebra 2 series next, and I can't wait for that. So this is going to be the final video of the Algebra 1 series, as I just said. And one more big favor, please remember to like and subscribe for more awesome content just like this. Without further ado, let's move on to our answers to our previous questions. Last video, I gave you 2 questions instead of normal 3, and these 2 were graphing questions. And I'll show you the answers right now. For our first question, this is how the graph should look about, but it could look a little different, but nothing too crazy. It should be a little bit above the x-axis, and with that standard square root type curve. So that's basically how the first graph should look. And for the second graph, as I'm going to show you right now, it should look kind of like this. More like the negative form of the square root, except more steep in the early run because it's 2 times, negative 2 times the square root of x. I think it's time to move on to the lesson. Today's lesson is about solving and graphing linear inequalities. And I know it looks like I threw a bunch of this hieroglyphics, numbers, symbols, whatever. But don't worry, I'll explain it all right now. These 4 on the left, which I'm circling right now, these 4 are the inequality signs. This one means greater than, this one means less than, this one means greater than, this one means greater than or equal to, and this sign means less than or equal to. These are our 4 signs. Some of you might have learned that in pre-algebra, but if you haven't, that's just a review. Good thing you should know this because these are the primary signs in inequalities. Solving them is basically the same thing as solving linear equations. Like if I have 4x plus 5 is equal to 9, except it'll be like 4x plus 5 is maybe greater than 9 or less than 9 or greater than or equal to 9 or less than or equal to 9. One of those 4 possibilities for which one of them it's going to be, but otherwise the rules are the exact same, except one exception, which I'm going to demonstrate in the examples, but you can wait a little bit. This lesson is also kind of like a 2-in-1, where we have 2 topics, but they're very similarly related, and they're both very simple, so I think it should be fine to put them all into one video. The second topic that we're going to be talking about is graphing linear inequalities. Now, since we're only going to have one variable, like x, or y, or z, or a, or b, or whatever, what we're going to do is we're only going to have a number line. Normally, we would have a coordinate plane with 2 things like 0, 2. But this, it would only be like this. We would only mark it as 1, 2, 3. So kind of like one axis is the coordinate plane. Mostly if you're graphing linear inequalities, it's going to be horizontal because it's just much easier, trust me. And that's basically it, except for one more small mini thing in the lesson. This is called an open point, and this is called a closed point. So what an open point is let's say I have x is greater than 5. Actually, no, let's do 3 because it's on the plane. X is greater than 3. So it doesn't include 3 because it's not greater than or equal to. It doesn't include 3. So we would have an open point and then draw an arrow going to the direction where normally right would be greater, left would be less than. So in a small example, just to clear things up, let's say we would just have s is less than 0, open circle, kind of like a circle around that, and draw another line which goes to the left of it, and of course put the arrowhead at the end. And it's the same thing for less than or equal to, except we would just make this a closed point by making it all shaded in. I know that was a lot, so I think it'll be easier to clear up in the example. Today we have 4 examples just to be a little more thorough. And that's basically it. Let's start with the first example. X plus 4 is greater than 9. So x plus 4 is greater than 9 is easily solved. We just want to isolate the variable. So first we got to subtract 4 from both sides. X plus 4 minus 4 is greater than 9 minus 4, or x should be greater than 5. It's that simple. That's our solution. That's how we're going to do it. And if you're confused about the inequality stuff, just think of it like this. Just say, okay, instead we could just do x plus 4 is equal to 9. Solve for x the same way. If you know how to solve linear equations, which you should before going on to this topic. My previous video covered that. Trust me, you should watch them. And then you can just replace it with the inequality sign. But sooner or later, and preferably now, it would be much better if you just learn how to use the inequality signs. So it would be much better off for the final exception rule, which I'm going to show you in a little bit. But first, let's do our second example. Y is less than 3, we want to graph this. First, let me do the number line. With the number line done, we can focus on the open, close points, and which direction. What we can do is we have, okay, it's less than, not less than or equal to, or greater than or equal to. So it's going to be an open point. And since it's less than, it's going to be to the left. So what I would do is I would just stick in this line and put the arrowhead here. And this is how it would look. This is how the graph would look. And of course, this is very simple. And if you wanted to verify it, you can be like, okay, what's less than 3? Oh, easy, 1. Does 1 fall under the thickened line section? Yes, it does. That means that 1 is there. That means the line is correct. And if we have a close point, it just means that your line is incorrect. Instead of an open point, for this example, just make sure you see whether it's less than or equal to. The tip is to look at the line at the bottom. If there's a line at the bottom, that means it's less than / greater than or equal to. But if there's no line, that's just less than or greater than. This is our third example, which I just wrote up here. And it's going to be really easy to solve because it's just going to be like a linear equation. We want to isolate the variable, so we divide both sides by 2. X is greater than or equal to 7 divided by 2. What we have here is our fourth and final example, which I'm going to solve. And this is the one with the exception rule. It can kind of be solved 2 different ways, but I'm going to show you both ways just for thoroughness. One way is by adding 5 to both sides, so we get negative 2a is less than or equal to negative 8. Then we add 8 to both sides and subtract 2a from both sides. This becomes 8 is less than or equal to 2a, or 4 is less than or equal to a. But we normally want a on the left side, so we would just flip it and say a is greater than or equal to 4. For our second method, this is where the exception is going to come in. We start off with the same thing. Negative 2a is less than or equal to negative 8, sorry. And after that, we divide both sides by negative 2, getting a. But if we divide both sides by a negative number, we flip the sign. So greater than would, of course, be less than to greater than. I should have said that earlier, but that's how it goes. We just flip the sign whenever we're dividing by a negative number. So we get super simple here. A is greater than or equal to 4. But I also said we have to graph. So what we're going to do is we're going to draw the number line. So what we have here is our number line, which I'm going to extend because it's greater than or equal to 4. So we can have some more, like maybe 6 and 7, and then negative 5, negative 6, and then finally negative 7. We're going to start with a closed point this time because it's greater than or equal to, and then draw the line to the right, the thickened line to the right, so we know which one it's going to be. And in case you can't see that, what I'm going to do right now is I'm actually just going to draw for you in red line. So the point's going to be red, and then here's the line. 4, 5, 6, 7, and onwards. And this is just a general note. Whenever you're solving an equation, you're like, oh, okay, well, how do I know this is correct? Let's take the first one. X is greater than 5. Let's substitute a value which we know is greater than 5, like 7, and substitute it back into the original equation. 7 plus 4 is greater than 9, so 11 is greater than 9, which is true. So that's how you know if an equation is true or not. Let's move on to the practice problems. For today, we have 3 practice problems. Number 1, 7y minus 5 is greater than 16. Our second example is to graph x is greater or equal to 5. And our third example is to both solve and graph x minus 5 is less than or equal to -7. Thank you for listening/watching, and bye-bye. See you in the next one.